All right, gentlemen. So in ACR 130 module 2, your second set of EQs are entitled Multimeter Function, A Deeper Understanding. On the first day, I had you introduced to the basic tools and what a multimeter was. And then on this exercise, we watched a video and dove more deeply into the functions and how to use a multimeter. I don't expect all of you to be experts by now, but you need to have a basic understanding how to use the most important tool in an HVAC service tech's bag. And that is the multimeter. It can tell you so much information. So if you get a chance, review that video, and remember that in Teams, in your file, if you go to your Teams file list, you have resources that help you walk through the functions of a multimeter. So you have this one here that tells you how to use each function of a multimeter. And you also have, go back, oh, that's the same one. That's not the one I wanted. I don't think I got the image loaded in, but I do have the image. Hold on one second. I'll have to put it on Teams. Let me see here. You have this image that gives you a basic understanding of the most common functions, from AC DC voltage to non-contact voltage detectors. But the most common one you'll use is continuity and voltage. So we're not going to watch the video here. We are going to go through and answer these questions, assuming that you've already watched this video, and see if you have any questions. So list as many functions as possible about functions commonly found on a multimeter. Well, let's start with the ones right in front of us. You have AC DC voltage, AC DC amperage. Remember, the voltage is the push and the amperage is the work being done of the current. So a motor doing a lot of work will have a higher amp draw than a motor doing a little bit of work. You have the frequency, hertz. Everything's 60 in the United States. Resistance, how much the load pushes back on the current. Temperature, which is important for many reasons, including space temperature, box temperature. Is your thermostat reading right? Or your thermistor's reading correctly? Capacitance, or microfarads, to test capacitors that help permanent split capacitor motors get started. Diode testing. Continuity, whether a line's broken or not. And no contact voltage to see if you're working with a live circuit if you don't know. Those are some of the major functions associated with multimeters. There are many, many more, but make sure you know those at least. Which accessory must you use to test temperature? They're always called thermocouples, and they're K-type thermocouples. So for example, K, if you just type in K-type thermocouple, you find them in all kinds of different styles. The most common one is just a little yellow wire with the K-type adapter. Some are better insulated, some are probes, some are line clamps. But basically it's just reading the resistance through one wire back on the other. And this adapter is why it's called the K-type, the negative and the positive. This is the most common one you'll find. And let me find a clamp one. You'll find them on units themselves though. For example, on a defrost controller, on demand defrost, all the thermistors, that's all they are K-types. If you go back, I'm looking for a clamp. There's a probe, there's a common style. There we go. A line clamp thermocouple. All that is this wire with clamps that'll push it and make good contact on refrigerant piping. But if you go back to your Teams file, remember when it comes to checking temperature of thermistors, K-type thermistors or any type of thermistor, you have a resistance chart. Ow. In your resources. So I don't want to look it up. I want to move fast. Let me look one more time. It's in here, I know. But if you simply it was under sensor resistance. Compare your ohm reading of a resistor through this chart, and why it's taking so long, I have no idea. My computer's being stupid. Here's the basic ohm reading chart. So for example, a good benchmark is 32,000 ohms is approximately 32 degrees. Do you see that? 30 degrees is 34,500 ohms. 35 degrees is 29. Right in the middle there, 32,000 is approximately 32,000 ohms is approximately 32 degrees. And there's a reverse correlation. As your ohms goes up, your temperature drops. As your ohms go down at 185, you only have 1,000 ohms compared to 32,000 at freezing. So that's how you can test and see if a thermistor on a unit is bad. And you need to calibrate your own equipment and make sure your thermistors that you use in the field are good. You should test them regularly. Okay. Which function do you use to test power going into a unit? You will use, oh, wrong photo. AC alternating current with the squiggly line. You don't want the dashed line, which symbolizes DC, but you want to check volts going into your piece of equipment. What is the purpose of using the ohms function? The ohms function tests the resistance of a load, like a blower motor. If you do not have resistance, meaning you don't have a coil in the windings, that means that winding is open and that motor is bad. It will never run. So OL, or open line, is open windings in a motor, and that's a bad thing. Also, on a compressor, you have start, run, and common windings. They all should be closed together. That's one of the most common functions, is to test the resistance in windings in all loads. Testing the resistance through a coil on a contactor or relay. If it's open, that's a bad contactor, that's a bad relay. It's not going to work. When testing ohms, what does the symbol OL symbolize? Open line. That's like the coil that's wrapped around here. Somewhere in that line is broken. So L1 and L2 can't go through your load. Or your power in, your power back can't go through because the line is broken. What is continuity? To test just an audible. It's still testing ohms, still testing resistance, but the same as OL. If it's broken, it'll give you an audible beep. Not just a reading on your gauge, but an audible beep. That is usually symbolized in the speaker symbol on a meter. Not always, but usually. What is the units commonly used to measure capacitors? That would be capacitance, which is also this symbol, also known as microfarads, named after Michael Faraday, who invented the first stator rotor motor using the electromagnetic effect. Why is it important to change the leads back after checking capacitance? Oh, this is so very important. If you do not change your leads back, if it doesn't have an internal fuse on the circuit board of the meter, you will be guaranteed to blow that meter and it will be no good to you. If it does have an internal fuse, it'll save the meter, but you'll blow your fuse, and they're very specialized milliamp fuses. And if you don't have one, you're in big trouble. So make sure that you always change your lead back from microfarads to the correct position to check voltage and whatever before you apply voltage to those leads, or you'll burn up your meter. I was looking for a picture of that, but I'll get one here at the end. Which function would you use to test the windings of a motor or compressor? You would use resistance or ohms. What are common reasons to use AC voltage, reasons to use DC voltage? So here's what I want you to know here. Everything from the power company, because of the way it travels, is AC. You want to check and make sure the voltage matches the data tag on the equipment or the individual component. If not, if you have low volts, you'll overamp. If you have too many volts, you can burn up the component that it's running to. So you always want to confirm that you have proper voltage to make sure it's not causing problems. It will always be AC coming in. However, you can convert that to DC voltage anytime you want something to modulate. 0, 5, 10, 15, 20, 30 to 100%. DC voltage is much better for modulating things like actuators, dampers, whatever, inverted compressors. They will be converted to DC voltage. How will you know which one? Read the data tag. Which function do we use to measure the load or the work being done of a motor and compressor? You will measure the amperage around one leg. So say your power cord going to a light. You have a ground, L1, L2. You don't measure amperage around the whole cord. You have to split it apart and measure amperage with the light on just around L1 or L2. You don't want to measure the totality. You want to measure what the current is going through that circuit, which would be one wire. Where do you place your meter leads to test potential shock hazards in a circuit? If you remember, say we got a contactor and we have L1 coming in the top and L1 coming out of the bottom. If you put your leads on L1 and L1 and there's power there, you will read 0 voltage, because it's not designed to read power going through one conductor. It's meant to read the voltage going through an induced or resistive load. So you have to have a lead on L1 and L2 to read voltage. So if you put it on L1, L1 and read 0, you can still be shocked. How do you prevent that? When you open up a unit and there's 1,000 wires, before you touch anything, if you need to work on something, check it to ground. That will tell you the potential shock hazard every time. So find a good ground, but one lead on ground, one lead on the wire you're going to work on or the component, and that'll tell you if you can be shocked or not. Which function of a multimeter could you use in conjunction with refrigerant pressures to calculate superheat and subcooling? That would be a thermocouple. Be careful. If you test a live 240 volt circuit and place L1 on L1 or L2 on L2, you could be shocked because it'll read 0, because the meter cannot read the current through one conductor. It can only read the current going through an entire circuit And to have an entire circuit, you need negative and positive. So that's why on your leads, it'll literally label them common and hot, or black and red, which is the same as negative and positive. So make sure you review this video. Do you guys have any questions about these EQs? There will be several questions on your test about different functions and using them in different circumstances. So for example, what's the best way to know if a resistive heater is running? Do you know? You put an amp probe on it. 5 kilowatts, it pulls 20 amps. At 10 kilowatts, it pulls 40 amps. 15 kilowatts, it pulls 60 amps. You can tell if all your heaters are running by doing an amp draw. How do you tell if a compressor windings are open? You do a continuity test or an ohms draw. How do you tell if a unit is overamping due to low voltage? You check the supply voltage coming in. How do you check to see which component of a system is overamping and tripping your breaker? Which component is it? You can check the load voltage going to each individual component. So you can check the low voltage going just to the compressor, or low voltage going just to the condenser motor. Same thing. You can check the amperage going just to the inducer motor, or the amperage just going to the blower motor. The supply voltage is the supply to both components. The load is the voltage going to each individual component. Make sure you understand the difference. Any questions? All right, I'm going to give you a few to adjust your answers, and we'll let this video process. And if you have any questions at a later date, let me know.